What is burn to mint? Well, it's technology. It was developed by XRPL Labs, which is a team in the Netherlands led by Wietse Wind, and it allows you to stand up a sidechain that adds smart contracts. This takes real XRP from the mainnet into the Hooks sidechain. This technology is a genius way to handle the bridge. It's a permissionless environment for everyone. The first 10 minutes is explained by Lathan, an independent coder, and Chris, who is the CTO of BPM Wallet. It's about an hour and 15 minutes long. It does get very technical, but if you're a builder or a leader of a project with a dev team, you can learn how to utilize this code. Do enjoy.
Hi everyone, my name's Chris and with me today is Lathan. We're both developers on the XRP ledger, and this is our first attempt at a flying solo with making a video, and this is now our second attempt of the day. So yeah, we're going to talk today about burn to mint, but first of all, let's just talk a little bit about what we're trying to achieve. This is basically the first of what we hope will be many videos. Lathan and I both believe that there's no such thing as too much good quality content around developer-led content. And ultimately, that's what we want to do. We want to get as much content out as we possibly can to encourage other developers to come into the space, try and make their learning curve a little bit easier if they can actually see somebody having already done some of the more basic concepts that they can just quickly copy from. We're going to have a go today at our first video, and we're going to tackle the burn to mint protocol, which basically is a new thing that's going to be coming all wrapped up in the bigger conversation that is the Hooks sidechain. So before we get cracking, Lathan, anything you want to add?
Yeah, just a basic disclaimer that this code is not to be run against production. You'll lose your XRP if you're doing it there. So stick to testnet, and yeah, just be mindful of which networks you're connected to, because we're not just connecting to one network today. We're connecting to multiple.
Yeah. Okay, great. So how this is going to work is that Lathan's going to be driving. He's going to be doing the coding, and I'm going to try and be the map reader in the driver's seat. Try not to confuse him and disturb him too much with too many questions, but I'm going to attempt to sort of like give some narrative around it. And this is the first time we've tried this, so we're just going to sort of see what happens and have a go. So we start in on the burn to mint page, which is on the part of the Hooks testnet docs. So first of all, should we talk a little bit about, what the burn to mint actually is and why it's going to be important to get cracking, Lathan?
Yeah. Where do we want to dive in the docs? Do we want to kind of just...
Let's say, first of all, what actually is burn to mint, and why are we using it? What's it going to achieve for us?
So burn to mint is coming from XRPL Labs, which is trying to stand up their Hooks sidechain. A little bit of history around that. That Hooks is trying to add, obviously, a smart contract-like capabilities to the XRPL, but there's a lot of code to it. So the recommended path has kind of been to stand up a sidechain. Now, they didn't like too much the way of the XLS, I think it's 38D, that's put forward, the way that bridging mechanism works between the two networks. So they've spent a bit of time exploring some of the options that are out there that are available to them, and they've put together this thing called burn to mint, where they're using an older piece of code that they wrote for a while back, I can't remember, to do quote unquote offline payments. And they're using that to facilitate their mechanism to actually bridge XRP from the one ledger to the other. There are some other differences between the two implementations. I don't know if we want to go into that, or
I don't think so. I think that's fine. The whole point ultimately is that burn to mint is a way of taking XRP, real XRP, from the mainnet and getting it across into the, at the moment, the hooks sidechain. But technically, this process would work with any sidechain if it gets properly adopted, right? So, I personally love this whole thing. I think it's a fascinating way to do it. It's, you know, it's a decentralized way of approaching this. There's no centralized party involved in this. There's no locking up of assets. There's no sort of risk around, you know, that are usually inherent with other bridges. If you do this right, and again, this is my opinion, but if this is done right and the technology works as it should do, then I think this is just a genius way to handle the bridge, because what will enable us to do is to actually start on the XRP ledger mainnet, burn real XRP, as in destroy it, gone forever, never coming back, right? And then do this process of burn to mint we're going to talk about today on a different ledger, a sidechain, essentially create new XRP on that ledger. Okay, so the sidechain starts with no XRP. It doesn't have anything from day one. It's literally 0 XRP on that ledger. And the first person that would effectively import would be creating the first pieces of XRP that would exist on that ledger. And this is going to be a fantastic way of being able to move assets from the mainnet onto the sidechain, because it doesn't require any, once the actual code is in place, you don't have to do anything other than use the technology that is there. No one you got to go and get permission from. There's no one you trust in. As long as you do it yourself correctly, you're fine. As we get through the further conversation, and we will obviously get to the fact that at the moment this is going to be a one-way bridge. There are hopefully plans that we will eventually get this to go two ways. That is going to come from something called the import amendment, or at least that's what it's currently being called right now, the import amendment. But that will require effectively a vote on the mainnet, and as we all know, that is going to take some time to be able to get live. And there will be, I imagine, lots and lots of testing and audits needed to be done before anything like that could happen. Because if we effectively look at what that would mean, it's like reversing the process. So the XRP that you have destroyed on the mainnet that now is living on a sidechain, we're now talking about being able to reverse that. So destroy your XRP on the sidechain and recreate brand new XRP of the same value back onto the mainnet, which is politically sensitive, to say the least, because it's, you know, it's one of the traditional like fodder arguments about, you know, being able to make more XRP, which anybody that's done their research knows is not true. So there would be a huge amount of work going in around securing this to make sure that you will never be able to get more than the original supply on the mainnet. And obviously XRPL Labs are sort of like behind this, so I've got full confidence that when this thing is actually production ready, you know, that I'll be happy to use it and put my trust in that code. So we are just sort of like, you know, pioneering the first sort of like trials of this kind of stuff, and we want to share it with as many people that want to listen. So this video is probably going to be a little bit technical. It is geared more towards developers, but that doesn't mean you have to be a developer to watch it. You might find it fascinating, you might find it boring. Everyone's different. So what we're going to do, have a quick look at the docs, and then we're going to basically build a implementation of burn to mint, and we're going to be using the testnet to burn from, and then we're going to essentially mint onto the hooks sidechain testnet. Okay, so if we take a quick look at the documentation, there are a couple of key things to sort of bear in mind. Again, this is documentation. This is provided by XRPL Labs in order to try and help developers like us just to get sort of started. But there is a few things worth pointing out. This process is generally considered to be for enterprise use, although, you know, what that actually means in the real world is a matter of, you know, opinion. But nevertheless, this is highly technical, and it's not the sort of thing that an average user is going to be able to do unless they have either the technical skills or they are using a service that is provided by somebody that has had the technical skills to build an appropriate, trustworthy service to use. So, in order to do this, you're going to have to be running your own infrastructure. So if you're just a normal user thinking, this is cool, I'm going to do this, you'd have to know that you effectively going to have to be running your own infrastructure to be able to do that. And we're going to get into why that's necessary as we go through this. But as a general principle, we're going to have a couple of steps to this process. We're going to burn some XRP on the testnet, and then we are going to create something called an XPOP, which is effectively derived proof of that burn. And then we're going to take that proof and we're going to use it to create new XRP on the sidechain. That's the sort of the simplest explanation I can give of it. You want to add anything to that?
No, that's
okay.
a great introduction.
Right, let's just crack on then, and we'll sort of see how we go. We'll get into the weeds a little bit as we go through it. But we're sharing screens. Nathan's got open VS Code, and basically we are going to build out the equivalent of what he has got on one of his GitHub repositories. Shall I just show that now quickly? So anybody that wants to sort of see this code and go and run it themselves can find it here. So this is Lathan's repo. So you can go and clone it, and then you can obviously get the code if you want, and potentially follow along if you would want to. Right, over to you.
Okay, so when it comes to this process, we know there's kind of three basic steps to it: your burn, your XPOP, and then your import, right? The burn can be done in 3 ways. We're not going to get into the weeds of the more technical ones, which are basically around multisig. We'll probably talk about it right at the end. But for now, what we're going to be tackling is just trying to do an account set. So the first thing where we start is just get us you can see my VS Code, right?
Yeah.
Cool. We're going to get with a package.json, just define that, and then I'm just going to copy paste that because that's just boilerplate code. It's just a couple of imports that we need, but as we go through the code, those will become clear. So I've got that, and then we're going to create ourselves a new folder, source folder, and inside that we're going to create our main file. So I've got that up now. Just give me a second here. There we go.
You want to run an npm install before we forget and look foolish later?
Yeah, that's a good idea. So that's just fetching those base packages that we're using, which is just a bit of debug, XRPL client lib. And I probably should cover that now as well. XRPL.js, I'm not too sure exactly where that library is headed for some of the definition changes that are required to be able to run. There are some changes in the, what would you call them? The responses that come back from the Ripple nodes at the end of the day. So we're going to be using XRPL clients over XRPL.js. That's just something to be aware of, and we'll touch on it when we start defining the account lib. So the first thing, we're obviously going to need our XRPL client, just standard import of the library, and I'll leave it there. And I'll probably take those two. And then we're going to need to connect into two networks. We've got our testnet, which you're going to connect into, which is the XRPL testnet, obviously, that everyone's aware of. And then we've got our hook sidechain, right? And those are just two WebSockets into two different nodes on those networks. And then we're going to need our main function. Let's call it app for now. And so easy peasy. And we can do something. And right, so the first thing we're going to need to do is we're going to need to get account info of this account from the testnet. And the reason we need to do that is we need to find the, what is that? The sequence number, right? Mm-hmm. So let's do that right now. Const. So it's standard command. It's going to be count underscore. And then the account is just going to be the account, which we're going to create one now. And ledger index. Let's define it as we want the current ledger, right? So the next step now, we need a testnet XRPL address. The best thing to do that is just Google XRPL faucet. That'll take you off to the testnet faucet. Just go and create an account there. That's what I'm doing now, right now.
Yeah, I'll just show that on the screen now for anyone who wants to get to it quickly.
So there's my account that I created, and it's going to have a secret, which we'll call const key swap, right? Obviously, this kind of thing should go on. We'll be good devs today. I'm not kind of saying do it right. Let's do it.
Yeah, I can do it right. Yeah, getting environment variables.
We don't really, keys should never go in code, so we stick them in environment variables, often in environment variable, and then we're just going to need a bit of code up front here to import the, what is that? It's .env. So we need to import the actual environment variable. And .env, we just, that's telling it to go ahead and import. And now we will have an environment variable with our wallet in there, or the key, right? We can leave the wallet out here, but you can also go and define that if you wanted in the environment variable. But that's fine for now. So we're doing that, and where is it? Yeah. So now we need to go off, and we actually need to send that command to the XRPL. I'm just going to call it testnet info. What do you call it? Because you could query it twice. So anyhow, we're just going to be querying the first one. So there, we've defined our client up top here. That's the network we want to connect to. So it's going to be the testnet. We need to send our command, which is what we've defined up top there. And then we can actually go ahead and just pump that out. So this is pretty standard boilerplate code for anyone that's done this, any queries off to the XRPL before.
You're going to need to use the R address a couple of times. Do you want to put it in an environment variable, make your life simpler?
Yeah, we can do that. account. Leave it up there. I need to close that. This will be process. Here's a caps. Let's give that a go. Let's see if we actually get a response. Yeah. Okay. So all we've done there is we've gone and fetched the account info. And the main thing we're needing off here is going to be that sequence number, right?
Yeah.
Most transactions need that sequence number whenever you execute them on the XRP. So that's the first step. We've got the account. Now we actually need to construct a transaction to actually go and burn some XRP, right? And we're going to be basically doing just the account set today. So let's go ahead and create another function. And we're just going to call it burn. We're not going to do multiples here. I'll leave the more advanced ones to the repo that I've got up. So we've got our burn. And again, we're going to be doing another transaction across. So let's just call it a burn for now. And now it's going to be our transaction type. It's going to be account set.
Right. Should we just pause here and just explain about the transaction type options?
Yeah. So as I was kind of alluding to there are three options. You've got account set, you've got, I think it's regular key set, and then signer list set. Now, regular key set and signer list set are two of the more advanced ways, I would say, to actually burn some XRP. Those are really required for people that have got multi-sig set up, right? So if you've got a multi-sig account and you want to move your XRP from the testnet onto the Hook sidechain and not relinquish your security or your multiple signatures on those accounts, you would do that by updating your keys. And the way that we update those keys is going to be via signer list set. Red key would just be if you want to assign a new signer key, but anyhow, those are mainly focused to your kind of multi-sig, more, what was the word that you used before? Your more advanced kind of enterprise. There we go. The more enterprise user, right? So that would be like an exchange or someone, an exchange actually running a burn like this. They wouldn't want to compromise their multi-signature on their accounts. However, the method of when you update your signer list and actually burning XRP can facilitate that for them.
There's quite a key point to make around how the burn to mint actually works, because what we've done now is we've got an address on the testnet. That address does not yet exist on the sidechain. Okay, there's nothing there. There's nothing there. There's no XRP there at all. And the way in which you would obviously normally get XRP, so get activated wallet, would be to push some XRP into it. When you do the burn to mint process, the account actually, that is what creates and puts the XRP into the account, correct?
Yeah, and that's the way we're doing it now. But you could effectively, when I originally wrote this code, I had two existing accounts. I had an XRPL Hooks account that I was using for other testing, and I had my testnet account. So I would just be I link those two. But yeah, if it's a totally new account that's being used in this instance, then obviously we need to. There's a couple, when we get to that sequence number, we'll explain a bit further there.
Sure. Okay.
So let's do that. Let's flush out this transaction and get down to that sequence number, right? So account process I think I called it wallet. No,
address, I think you called it, didn't you? Account, yeah.
Right, so we defined our account. Now here comes
the
fun part.
Yeah.
Right. What we are going to burn. Right. So typically on the XRPL, you use a calculation to figure out your fee, right? You go and you query the server, you get its, what is it, the load or whatever, and then you apply some numerical calculations. I can't remember it off the top of my head, but anyhow, you can calculate the fee based on the load on the servers. Now, this transaction is not just going to be paying enough for the transaction to be added to the XRPL. What we're actually going to be doing is bumping that value up to something bigger. And that bigger value is what actually is going to be transferred across onto the Hook sidechain. So this fee value is what is actually going to be sent across. So I think to make things simple and easy to understand, we'll start out with 1 million, right? So that's one XRP or 1 million drops. Easy to, or let's make it 2. So it's easy to identify, right? We'll start off with that. There's still some unknowns around this, as this is still being worked out, whether this fee, with the fees and how the actual value that moves across. So just FYI, this value, because at the moment today, as the code exists, it's 1-to-1. It's going to create you 2 million. It's not going to actually subtract the fee that you still have to pay the XRPL ledger on the testnet, right? So just be aware that this value might actually change as things progress. And now we get to something of a new field, but it's not really a new field. It's a pre-existing field that's existed in the ledger for a long time that XRPL labs are, what do you call, co-opting or utilizing. It's called operation limit, right? An operation limit, what we need to stick in there, this is going to be the ID of the network that we're connecting to. Now it's going to tell us, and we're going to want to connect to the Hook sidechain. At the moment, that's not a string, that's an actual number. That's its value at the moment. That will obviously change if maybe a version 4 of Hooks comes out. I think that value actually updates. So look back to XRPL Labs for their documentation. They should be providing you that number. I'm guessing there'll become some helper functions that'll actually spit that number out for you. So you could go like, what is it? System_info, I think is the one. And that would return you what the current ledger is and so forth. And in there, I think is the number as well.
Mm-hmm. You need to fix that typo on operation limit.
Right, operation limit. I'm not 100% sure if flag needs to be here, but I've added it, so I'll do the same. We're just picking flag 0. I don't think that has any influence on account set, if I'm not mistaken, right? And and that's the other thing you could also talk to is if you wanted to actually set something on the account. I know you can do, I think it's the domain or whatever, the domain field on the account set transaction, whereby you could actually go and spec out, I don't know, whatever domain you wanted, like google.com or whatever. And that updates on your XRPL account. You can do those extra transaction settings in here as well. So you don't have to be just burning, but you could be effectively updating a value as well.
It's quite an important point, actually, because what we're doing is we're piggybacking off the back of a legitimate transaction account set to do the burn. We're using the fee of that transaction to do the burn, but effectively we're doing a transaction which is kind of meaningless now. It's just there so we can burn the fee.
100%. And now we get to our sequence number, right? Now sequence, you need to go back onto your testnet account and actually find what is the sequence number. This is not sequence 0 if I'm if I'm not mistaken, right?
Yeah, this is going to be the actual sequence, the next sequence.
Yeah. So let's actually look at our debug that came back out there. We know it's under account info, then account data, and down the bottom is our sequence, right? Account info, account data, sequence. So that's the value. And the reason why we queried that up top. We actually need to pass that across, right? Yeah, I've got it defined there. I need it. So test info, there we go. So that's going to actually be doing our burn now, right? And again, we're going to need to submit this to the XRPL. And to do that, we obviously need to sign the transaction, right? Now, because this is dev code, we're going to be signing here in the code itself using the libraries available. But obviously, this will be done via connecting to Sum and pushing your signed transaction through Sum or whatever wallet, Gem wallet, or BPM or whatever's out there, right? So to do that, we need to first we're going to need to import the libraries, and then we're going to touch on this account definitions.
Yeah.
So let's do that. So I'll jump back up to the top. We're importing XRPL account lib. What this library allows you to do is to actually sign transactions, derive addresses. There's a whole bunch of other things. You can get the address in hex format. And if you're doing multi-sig, you'll probably know about this library already. So we're going to be using that to derive our, actually make our transaction sign. But this has actually got definition changes in it that are coming down the pipeline. I'm not 100% sure exactly how the technicality of it sit together, but there's a definition change that needs to be applied at the moment. And that file, how do we cover this here, Chris? Because at the moment, I have to go off and just put it on screen so people can see it. Right?
Yeah.
You need to go off and you actually need to pull down the definitions from the burn server, or burn node, effectively, right? And this is one of the new bits that is coming in, right? So to actually move the XRP across, this burn node is all it's effectively doing is producing the XPOP. And that XPOP is just that Merkle tree of the transactions that have happened, and it's fetching your transaction with its full Merkle tree that can then be validated on the hooks net.
Bringing across the actual documentation that's talking about these definitions now.
So yeah, we need to go and update the definition that's housed in this account lib. Now you could go and pull it yourself via this call command, get it down, and then stick the value into a file, which is basically what I've got. Let's just, to make it easy, I think I'm just going to copy what I've done in my repo for now. So just create a new JSON file, just call it definitions or whatever you want to call it, right? You run that call command. It's in my repo. You can grab it off there. And that's just a definition of the different functions that are available on the actual node, right? Now we need to be using new definitions here, which is going to be our import transaction. So if I look for that, import, just bear with me for a second. There we go. No. Exactly where it is. But anyhow, the import, it's the new definition is going to be using is going to be the import, which is the final step in our process here. Remember, we're doing 3 main steps, which is getting the account info, then we're burning it, doing the XPOP, fetching the XPOP, and then finally submitting that transaction. That submission is a new, what do we call it, definition at the end of the day, right? So that's the reason for updating this, because this account lib is only set to work off the mainnet function types.
It's also worth saying at this point as well that this is having to be run against a modified version of the Ripple D, right?
Yeah, and the only thing that's modified on it is basically it's listening there on ledger close and generating that XPOP, and all that XPOP is your Merkle tree of those transactions, right? And that's what we're going to be going and fetching it soon enough. So yeah, let's get back to our definition thing over here. So we've gone and fetched our testnet 3 updated definition. We've dumped it in this definitions file. Now back over here on account lib, we need to go and actually use that. So it's going to be, we're going to create another const, just call it defs, and we need to require that file, right? So it's going to be, we're back one level from our current source directory, and I think we call it definitions.json. Right, so that's housing our definition there. We've got our account lib, and now we're going to actually instantiate this account lib with those definitions. And the way we do that is we define a definition, or definitions. Yeah, I'll just do it like that now. And the way we do that is the definitions over here, we're passing that def into the library thing. So now that we've got that set up, we can come back down here.
Before you do that, you've got a typo in your import. First one.
That one?
Yeah, on the file name.
Yeah, that should be better. We've got our back down to our burn, which is now we need to go ahead and actually sign this transaction, right? So before we can actually pass it off to the ledger and get it submitted, we need to sign the transaction. And the way we do that is something like this: conf master assigned to derive. We've got that right now. So family seed.
We got to pass in the R address now, right? Sorry, now we need the key now. Sorry.
Yeah. So now we're using that we're using that library that we defined above. Sorry, I just lost my spot over there. Nearly there.
So we're going to grab the key now out of the environment variables, aren't we?
Yeah, 100%. So we're using our library we defined above. We're deriving the family seed from our actual secret key now, and this is the part that should never be in code, right? So we're pulling that out of there. So it's going to be process.env dot key. I'm mistaken. And something really important here to understand as well is this secret key for your account. It's the same on every single network that is a fork of the XRPL. So if I had to sign this transaction on mainnet, I'm going to be using that key. If I have to sign that same transaction on testnet, I'll be using the same key for that R address, right? So my R address and your key value pair is the same across all the different networks. So hook sidechain, testnet, mainnet, all of them. And that's why very, very important about these keys. Keep them safe, don't mix them up, and if you reveal it on one network, it's actually revealed across all the networks, right? So be very aware of that.
Yeah. Right, so we want to get the signed transaction next, right?
Yeah. So the next bit is we go const. I know it passes back an object here, so it's signed transaction. And to lib sign. So now we're actually signing our transaction, which is going to be our transaction up here. We're passing the transaction and we pass in our derived family.
Yep.
Simple enough, I think. So at this point in time, we've signed the transaction. We need to actually submit it, right?
Yep.
Const, just call it result. Signed. No wait. And we're going to be connecting to the testnet that we defined up here. So it's that testnet.send, if I'm not mistaken.
Yep.
And it's going to be
submit command.
Submit. Blob. We pass the transaction. Right. We can actually run this now, even though we're partially through. And what's going to happen is that the I want to cover that. Yeah. So we're not going to be standing up a burn node here. We'll be connecting to one that's publicly available.
Yep.
So if I run this transaction now, that burn node is going to pick up the actual account set that is done here, and it's going to go ahead and actually create a XPOP, right? So I don't know if you want me to run that now. So because this is a valid transaction at this very point in time.
Yeah.
Or do we rather want to go ahead to the next step of actually saying, okay, let's go back next?
Yeah, we know that's going to work, don't we? So we know that we're going to do a simple account set, but the important thing is we've got a massively over amount in the fee, which is essentially going to burn that amount now. Yeah. So yeah, if we return that back, did you write a calling function for it yet?
No, I haven't. Let's go up to the top and do that. So it's just going to be await your burn. We're passing in the what's going on? We're passing in our connection. No, our result. Yeah. So we've got that, and the next step now is going to actually be going to fetch the XPOP, right? So fetch.
You're going to need the hash off of the burn token that's returned.
We need the hash. Oh, right. And the reason we need that hash is because we need to go back to the XPOP server now and pass it the hash so we know which transaction to be fetching, right?
Yeah. Right.
And that we're also going to need to hold the actual XPOP that comes back. So just that.
Yeah.
Let's go and define that function now down below. We've actually got our function now, and I think the way that I was doing it was just using Axios. So that's going to be another import.
You're not going to pass the hash into that though.
Yeah, I'm just going back and pulling out Axios, which is just the lib I like using to actually fetch REST requests.
Yeah.
So in here, we've got the hash that we've now got, and we need to go and actually try and fetch this, right?
This is the interesting thing now, because this is where Axios comes into this, isn't it now?
Yeah, so what we're doing is we're doing a REST request off to that burn server. I'm guessing eventually that becomes standard functions on your client, so your XRPL client. You just call off through the client at the end of the day. But for now, because this is a modification to the way that node is stood up, it's an external thing that we have to go and fetch off the server. So that node is just basically saving these JSON blobs and making them available on HTTP. And now we're going across HTTP and putting them back down.
Yeah. Before we get into that, then let's just quickly talk about what has actually happened at this stage. So we've burned our tokens, and this is quite an important part of the mechanism to understand. So the tokens get burned, the ledger closes, and once the ledger is closed, essentially the modified version of Ripple is looking now for a burn. Okay, when he finds the burn, at that point it's creating the XPOP, and at this stage the XPOP effectively is just stored on the local file system, right?
Yep, and we're going to go and fetch that now.
Yep.
And this is nothing new. That XPOP's been around for a while. So the definition of the burn server, I don't think is really up for debate. I mean, that XPOP has been defined and been played with for a while. So we're just setting the some headers, getting some JSON, and making sure we're getting UTF-8. And then I'm not going to type it. I'm just going to copy paste that. Put that there.
And so like you said, this is likely to change, right? I mean, a more elegant solution to this is most likely going to be forthcoming, right?
Yeah. So like we're using the we're using testnet new XRPL client, and you're connecting in via that WebSocket, and then you've got functions to actually go and get account info and so forth. I'm guessing the equivalent will come around whereby you'll be able to go and say get XPOP info or whatever it is, right? And do a send command.
Yeah.
In place of actually fetching it via the HTTP. That's my guess how it will actually shake out at the end of the day. So here we're actually doing our HTTP request. All we're doing is that we're saving the data that's coming back from it. We're doing an await asynchronous request off to the testnet server that's publicly available at the moment. These will change depending how things are developed and move around. So look out for other burn servers and so forth. And that'll probably be updated on that some documentation or XRPL Labs documentation page, right?
But the important thing is we're passing the hash through now here. That is the key point now, right?
Yeah. So if I actually go to, let me just get a browser open here. Can I see this? No, just hang on a second. Just jump out of that for a second. Come here. These are all the XPOPs that people have run at the moment, right? So this is the server we're connecting with, and now we're just looking for our hash, whichever one of these is ours, right? And then we're going to pull that file down. That's exactly what we're doing at this point in time. So those are public, right? Anyone can look at them. There's no, they're not private by any means. So we've got our data, but now we have to transform our data now that comes back off of the results of that. We need it in a, what is it, a buffer, if I'm not mistaken, further on. So we'll do that now. Buffer. I don't know why my autocomplete has just decided not to enjoy.
Yeah, so it's not helpful for your autocomplete to drop.
Eight. Right. So that's it. So we've got a data return there.
One thing that would be cool to explain here, right, is I'm just looking at the repo while you're doing this. obviously you've got a catch and a retry. Okay, what's your thought process around having to have the necessity of a retry?
Well, one, they just take 3.8 seconds to close between them. So we need to wait at minimum 3.8 seconds for that ledger to close. You could either sit here and just put in a wait, like a pause, and just say, okay, wait for who knows how long. But it could even take longer, depending. I know some of these, I think the set signer list is a bit more heavy on the node. And you don't know exactly which ledger it's going to close in that transaction that came above. So we might be sitting here for a couple of ledgers, and we try and look just every couple of seconds to say, okay, by now it should be here, kind of thing. So that's what we kind of need to do here, right? So let's go and do that. So we're going to catch the exception. We don't really care about the exception, and all we're going to do, we need to have a retry. You can do it however many you want, but I'm guessing something like 5 or 10 before you actually like kind of fall over and fail, right? So we're going to say if retry is greater than 0. We're gonna wait. We're gonna wait for a little bit and then go retry this. So we'll put in the pause function here, and here we're gonna call back on ourselves and retry and fetch this thing, right? So it's just gonna be calling back yourself, the hash value that we've got there, and retry, but we're gonna decrement it by 1. So this will retry that amount of times. And you could actually, if you, at the bottom, if we don't find any results after those retries, we can just return a false, and then we can handle that case. So that's basically that. I need to go and write that pause function. So let's do, I'm just going to copy paste that. It's nothing special. Pause. So we give ourselves a pause function. Pause is just doing a promise and waiting the amount of milliseconds passed to it. So there it's waiting 1. We probably up that to, I would say anything past 3.8, but a decent amount of time is like kind of about 5 seconds, 4 seconds, around about there. You can fiddle that to whatever you want. If you want to try and be super fast, but I think 5 seconds is decent. So we've got that. What is the next step now? So we're actually returning now our XPOP.
Yeah, so we now got our XPOP returned into, is it XPOP? Yeah, XPOP. So we should probably check it's actually got some content.
Yes, and something like that. So if it's not our false, then we're actually going to do something with it. And we need another function here, which is probably going to be mint tokens, and this needs a whole bunch of parameters, if I'm not mistaken.
You need the hooks info, which is the original call. Did you do that yet? I don't think you did. No.
And the other thing to be aware of, we're going to be assigning 2 transactions. We sign one to burn, and we sign one when we import or mint, right? We need to use the same master key or that same key at both points, right? You can't be changing up your accounts in the middle. So we need the info from, and the reason I was doing that, what is it, hooks info. What do I call it?
Well, you need the hooks info for the sequence number, right?
Yeah, but because it's a new account, we don't really need it. So if you're doing if your account already exists on the hooks network, then you need to go and update its sequence number when submitting this mint transaction that we're going to write. Otherwise, you're obviously going to be starting off with 0, but we'll stick it in there for now. So we pass that along, and I'm guessing we need our XPOP.
You want to await that as well?
Pardon?
You're going to await that.
Ah, right. So we've got that. How do you close this thing? Basic function. Oh. Right. Now, let me get my head.
That's the magic bit, isn't it?
Yeah. Right. So we're going to be doing our mint now. Constant, just a normal transaction. There's going to be type that out. Transaction type is going to be, this is our new transaction type, and this is the reason for that definition change, right?
Yeah.
So we've got that import. The account is going to be our account process.
Yeah. The key thing is this is the same R address.
Yeah. So we're using that same R address now. And we need to pass it the blob. And the blob is the bit that's actually with our XPOP over here, right? So XPOP dot to string X. So we're converting that XPOP into a hex string, and then it also needs to go to uppercase. Yeah, I didn't get typos in that. Yeah, it looks fine. Looks fine. And now we've got our sequence number, right? And because we've not created accounts on the Hooks sidechain for this new account that we just grabbed off the faucet, that number is going to be 0 for now. But we can actually write a ternary.
No, it'll hand pull over the docs and show that little bit now. This was it's a kind of key point now. If it is your first, the first transaction or the first time you're going to import to this account and it doesn't exist, 0 needs to be the sequence number. But if you've already done it and this is a second import to that account, or if the account already existed, that's the point at which we need the sequence number, and that was the reason why we've fetched the account earlier on. So, but now we could just pass in 0 because we know it'll work first time. But if we do a second run, it'll then fail.
Yeah.
You want to pass in 0, or do you want to do a ternary straight away?
I have to do the ternary.
Okay.
Don't be lazy. So hooks info. We're looking for the account. So the account data. If that's undefined in the response, it means it couldn't find the account or
account info.
Yeah. If that equals undefined, then we know we need to return 0. Otherwise, we need to go and get the sequence number, which is further on. I had an example with it here. Ooh. Sequence. There we go. Sequence, data.sequence. So back down to our ternary. Hook info, account, data, sequence. And if our initial response is undefined, we know we need to set 0. So that's all we're basically handling here, is if the account already exists, go and get its sequence number and plug it in. Otherwise, we know it needs to be 0. So that's that. Then the next bit is we need to pay something, but actually they've defined it for us as a 0 fee. And the reason they've done that, do you want to cover a bit of that or not?
Oh, you go ahead.
The reason they've done a 0 fee here is that they don't want to be double charging people the transaction, right? You've already paid on the mainnet whatever the transaction fees for that network, and the imports across. I personally think it should have a little bit of a fee on it, or network, whatever the hooks sidechain has got, but that's the decision that's there at the moment. So we'll stick to it. The way that the XRPL protects itself is via fees, right? So the question then becomes around abuse of this function, the import function. You could just run it a million times. It's not, you're not paying anything for it. So what? But there are other mechanisms that are sitting there. I think there's a hash or something up front that actually, a hash table that's got, if the, what would you call it, the transaction was already sent, that it's not going to flood the nodes. So that's like one of the things we worry about as XRPL developers, that we're not going to hammer out those nodes, right? So that's a question mark still for me, whether that should stick or not.
I suppose it depends on how much actual grunt work is required before they realize that the transaction has already been used and block it.
Well, there's a whole bunch of things just in the way that everything's set up, right? Like, if you're moving XRP across, if you're trying to keep the things, are they effectively one-to-one or not? That whole debate then has implications down onto these fees, right? Then you need to make sure that your decimals are all the same and so forth. So it's everything has its knock on, and yeah, it'll be the right thing and the best thing at the end of the day, however it's set up. But yeah, neither here nor there. And the other field we need to pass along is we also need to tell it the network ID. I find this one a little bit strange because it is the network that you're importing onto already. So I think it's a frivolous field at the end of the day. But again, that's that hooks sidechain that we defined further up. There we go, on the operation limit when we did our burn, right? Same network ID over here. Hopefully that comes through in a helper function later on as well. Or it might exist and I just don't know about it. So we've got our mint. What's the next step?
Well, we need to create a transaction. So I suppose you can copy and paste that the master from the family seed, I suppose.
Yeah, so we need to sign and submit the transaction the same as that we did for the burn, right? So it's going to be basically that. Let's just take that down, stick it over here. I'm guessing we derive our family seed, that's fine. The transaction, our transaction is different now. We're not burning, we're actually minting. We're using our master key to sign it.
We also have to pass the definitions through here as well, don't we?
There we go. Yes. So that definitions that we defined all the way at the top, we need to pass into this library so it's aware of that extra definition of import. That we should have ready in there. So we'll plug that in. And what's after that?
Just got to send the transaction now.
So we're done. Wow.
Yeah, just get it sent.
Minted. Network is hook for hooks. Hook.send. Function command can be submit. And the blob is going to be our signed transaction. Right. How confident are we?
I think we should do, if we go back to the main function, we should close off the connections. That's all we really need to do, is just close off the connections at the end.
Yeah. So this step you should always be doing on your, especially your front end functions. Whenever you connect to the network, go ahead and actually close the connection. Otherwise, the servers, the nodes sit around just like hoping that your connection is going to come back, right? Because it's WebSockets, they'll wait a bit for them. But if you say, hey, I'm done, you can take back your resources and go and process someone else's transactions. Always a good thing. XPOP, that needs to close.
And you're gonna.
I've got the wrong things.
Yeah, you're gonna close the testnet and the hooks. No.
There we go.
Is that what you called them?
Good. Info. No, it's not the info.
Testnet.
Testnet.
At the top.
There we go.
Yeah.
And oops.
Well, I've been following along and I haven't spotted anything that I haven't shouted out. So I don't know. I suppose this is where we run it and see if it works. You got a plan on how we're going to actually show it having burned and then minted?
Yeah, let's actually go and look at those accounts up front before we actually run it, right? So people know that. Put that down here. Open this up. So yeah, we've got we're connected to testnet. Hooks testnet. I'm going to go and look for that account.
So that's good.
Doesn't exist. And if we go to the testnet, and throw in the account, there's our account with our XRP that was grabbed from the faucet, right? So we've got that 10,000 base XRP. So again, our account doesn't exist, but here it does. And we're going to be moving, I think it was 2 XRP was planned, right? So 2 XRP should be moved across into, and the account should be created over here. So with that.
Are you ready to step through if it falls?
There we go. Yeah, we got something off. Unexpected end of JSON. What line? Unexpected end.
Well, I'll pause the video now while we quickly fix the issue, and then we can come back. Okay?
Yeah, let's do that.
Okay, that should be recording again.
Right, let's give it another go. Non-dev. Yeah, so we've burnt XRP now. Now we're looking back at the sidechain fetching the XPOP, and all this green is the actual submission, right? So let's go back to our explorers, and then we'll come look at the output. On my screen. We should see a drop of 2 XRP over here, which will be that one. And if we come to our side chain here, and we want to look for our address, let's grab that address. Here's our address and the import that just ran, which is great. So it's successfully run. And if we kind of go over the just our outputs over here, see if we can grab anything. I don't think we put too much debug. Just our response. Yeah. So maybe just that. Sorry, I'm waffling here a little bit. Let me just get back to where I want to go. That whole big green number that we're seeing over there is the actual XPOP. That's this bit. If you go back and watch the video where Richard introduced XPOP at the Apex that he did via video over there, he defined that those blobs can be quite big in size, and that's the reasoning behind that thing being so much data, right? They're pretty big, so there's a fair amount of data going through that. Yeah. How do you want to sum this up?
Well, that is XPOP literally from the ground up, isn't it? I mean, it's so well. It's taken over an hour, I think, to do that. So it's taken probably about 50 minutes to code it, right? When you distill it down, it's actually pretty simple what it's doing, but it's actually, but it's equally genius. Simplicity is the genius.
I really like the way that they've put it together, whereby I mean, we're reusing really what's on the ledger, right? I mean, there's very little new glue that's kind of coming into the equation here. One, you've got the burn in the middle, that burn, which is the XPOP, which they've introduced before. People have had a lot of time to look at that code. And two is the import then on their network, right, which is going to come back as the amendment back onto the main net. Is all the new code that's kind of gluing this lot together. I mean, that's beautiful.
And no third-party involvement at all. That to me is for me why I think this is genius. And when the import works both ways, the ability to be able to move your XRP from one chain, the main chain, to a side chain and back, I think that becomes almost game-changing for the ledger now. And it opens the ledger up to a whole world of horizontal scaling opportunities which don't really exist now. So I'm really excited about what this can mean. So yeah, I hope that anybody that's watched this to the end has has enjoyed it and has actually got something from it. I think we've gone pretty slow, and we've really kind of explained in quite a lot of detail, I think, as you've gone through it. For many people that they've been building on the ledger, a lot of what we've been doing is just boilerplate stuff that's done all the time, right? That is almost the genius of the burn to mint idea. Is it's a lot of what you're doing is actually just standard functions that exist today. So yeah.
There's one last thing I want to throw in here at the end that's just important to highlight as well. Right? I mean, there's all the other bridges have got these custodial wallets whereby you send XRP, they build up a wallet that's holding back that XRP, and then when you move it back across, then they release some of the XRP back out, right? So there's this big honeypot. Yeah. We don't have this.
Yeah, this is the thing. This is what's genius about it. It's just such a huge target for someone to go after, and obviously this that just doesn't exist with this method, does it? It's that XRP is destroyed, and we've proven and shown that the XRP, when it goes across, it is gone. And anybody that wanted to sort of like do a calculation on the circulating supply would see the actual circulating supply drop as a result of the burn. So if you were to move, say, 1 billion XRP across the XPOP, I don't know whether, I mean, bridge is a strange word. It's almost like it is technically a bridge, but it doesn't work like traditional bridges, does it? So it feels like we almost need a slightly different term for it. But if you did move 1 billion XRP from the mainnet over to the hooks net, and then you looked at the circulating supply on something like CoinMarketCap, the XRP circulating supply will drop 1 billion XRP. It's gone. It doesn't exist anymore. It's the equivalent of the burning that's been going on since day one for the fees. And the only way that's ever going to be able to get back is if the import function ends up getting on the mainnet, which I think, I mean, I can understand why there's going to be a lot of concern over doing it, but I think if the appropriate measures are put in place to make sure it's safe and there's no issues with it, then I think that one thing becomes game-changing. So much so that if the hooks amendment never got onto the mainnet, hooks is not wasted. You know, I could see massive amounts of use case then potentially being built on the hook sidechain rather than the mainnet. I really, like I say, when I said horizontal scaling, you could see how people could build out sidechains for very specific use cases. And like I say, I really do think this could be game changing for the XRPL. But yeah, this has been fun, and I mean we've been on for sort of like about an hour and 10, hour and 15 minutes doing it now, and hopefully it's been helpful for people. We should, you know, send us some feedback on it. You know, my Twitter is at XRPL365, and Nathan, yours is at short FOMO, right? So
yep.
Send us some feedback on the video if you've enjoyed watching it, and we certainly want to do more like this, and we're also hoping that other developers will also jump on the bandwagon, right, and do something similar.
Yeah, this is hopefully the start in a journey in trying to get more devs some screen time and a standard place to go and look up for some dev help and maybe exploration on the ledgers. Yeah, that's the plan. Let's see if we can do it.
Right. Okay, let's sign off then. Thank you everybody for watching. See ya.
Cheers.